Hello. Hello. Okay. So, good evening, whatever whoever is watching, and we are back with the stream again. And yeah, we'll continue on with the DP series that we are doing, and we'll solve the problems that we did not and were not able to solve previously. One of which is sushi and this problem. Okay, so yeah, where's my whiteboard? Okay, so we are given n dishes, basically n plates, and each plate has either one, two, or three piece of sushi on it. Okay, so we are given n plates or dishes. Okay, and AI is the number of sushis on it. Okay, so what is asked from us is that when we roll a die that shows a number from 1 to n with equal probabilities, and let I be its outcome. If there are some pieces of sushi on dish I, eat one of them. If there is none, do nothing. Find the expected number of times the operation is performed before all the pieces of sushi are eaten. Okay, so before all the pieces of sushi are eaten. Okay. Uh, let's look at some of the sample outputs. Okay, here we have the answer is 5.5, and the explanation given is as that they have added the expected total number of expected operation for each sushi eaten, and then that was returned as the returned as the final output. Okay, so number of expected operation required to remove or eat one sushi, and that is then added to give the expected answer. Okay, so So suppose we have a DP state, or rather, let's make an observation here. You see, we have one, two, or three sushis on the plates, right? So, for example, this test case, one, we have three one sushi plates, okay, and we don't have any plates with two sushis, and we don't have any plates with three sushis. So the answer will be from this only. What will be the expected answer when we have three plates of one sushi? Then what is the expected number of operations before all the sushi are eaten? Okay. So you see, if we have a plate of sushi with three sushis on it, if we choose that one, it will become a plate of sushi with two sushis on it. So 3, if we choose 3, it contributes to 2, and if we choose 2, it contributes to 1, and if we choose 1, then it doesn't contribute anymore, it will become 0, right? So for example, let me take another example. Okay, this one. Here we have one plate sushi, two plates. We have two sushi, 3 plates, and we have 3 sushi, 5 plates. Okay, so let's say we start with these numbers, okay, and we can choose any one of the plate, right? So since it is equal probability, so what is the probability of choosing two plate two sushi, basically what is the probability of choosing a plate which has one sushi only? So it is nothing but what, like 2 divided by 2 plus 3 plus 5, right? Similarly for this, it is 3 divided by 2 plus 3 plus 5. Okay, for this also it is 5 divided by 2 plus 3 plus 5. Okay, this is the probability of choosing one. Alright, and what if okay, so this is the probability of choosing one out of this. And if we have chosen one, and if we have chosen a plate with if we have chosen a plate with one sushi on it, then we have only one plate remaining with one sushi, and the rest is 3 and 5, right? So these two events are basically just after another, right? So they are like together. So we do this and we do this, kind of like that. So I think it should be multiplication, because addition is not really uh, possible here, because I don't see how this is added together. uh, Most likely it is going to be multiplied. Okay, so it is like this. So we have two, we had two, and the probability of then choosing the and then the choosing. Okay, uh, this thing is correct, I think, but I'm sure that it goes like this only. When you choose a number out of this, right? When you choose two out of all these, or when you choose a one sushi out of all these, we have this probability. And if you multiply, it with the count, that will give us the expected value. And we want to calculate the expected value. Okay, I'm pretty sure it is like this, but we should not. We should be sure of our solution. So, okay, not this one. Yeah, see, if we take a sushi out of a pile of with three sushi, then we have a pile two sushi now. TDP, of course. Why is there n here? Okay, so you see, the probability of let's say we the our DP state itself will give me the probability of my will give me the probability of this current state, right? Let's say this itself returns the probability. Okay, so I have like I, J and K. Okay, so if I choose 2 here, if I choose a pile of 1 here, then what will be the probability? Basically 2. What will be the expected number of operations we need to perform? That will be 2, that is the amount we have. So it will be like this, I into Pi, something like that. That is the expected value, right? So similarly, in the case of one pile of 1 sushi, it will be 2 into probability that we have taken from a pile of 1, right? So it will be I minus 1 J K. We have taken this and divided by and that is divided by that is not divided by, that is the expected number, right? Expected value. Similarly, for other states we'll also add the same. Okay, it will be I plus 1 J minus 1 K, and here also for 5 it will be I J plus 1 K minus 1. Okay, so all of the expected operations are added together now, and then we will divide it from the total number of piles, or basically total number of sushi plates, that is x, y, z. This will give us the probability. This will give us the probability of this state. Okay. So yeah. So this is the transition function. Okay. So this is the transition function. We have different piles of sushis, and we are choosing from one of them, and then calculating our expected answer from it. Okay, so let's say what will our state be. It will be like this: dp I j k and this will contain the expected number of operations to clear plates clear I plates of one sushi j plates of two sushis and k plates of three sushis. Okay, and then the transition we already have this. So transition, it will be this. So dp I j k will be 0 when x is less than equal to 0 or y is less than equal to 0 or not xy, I is less than equal to 0 or j is less than equal to 0 or k is less than equal to 0. Okay, so basically if you don't have any sushi plates, then we don't have to make any move, right? So that is all. And if we have, then the expected number of operations will be we take I multiply it with -1 k j k. Okay, add it with this j into dp I plus 1 j minus 1 k, then add it with k dp I j plus 1 k minus 1, and divide it all with the total number of sushi plates present at that state. Okay, that will be the expected number for that state. Okay, an answer will be in base case is here only, right? This is our base case. Okay, so our answer will be dp of the count of plate 1 and count of plate 2 and count of plate 3. Okay, and yeah, so this should be the solution. And we are at 38. Copy this, not this, copy this. Okay, so input n, and then we will have a vector that will contain the values okay, and we also want something that will store the count. Okay, so this should work. Now we'll do mpi plus plus, and our dp will be a 3D dp, of course, because we have 3 states that are changing. And copy this. Our dp will be double dp, sorry, the size of it, the size can vary, but we are going to give it a 301 because at max we can have the array with all the elements with the same elements in all the positions. So in that case, okay, similarly here and here, and everything is 0 at first. And so you see here in the state, I and j are not really increasing or decreasing with the states. I mean, if you see here, in one state we are dependent on both I minus 1 and I plus 1 of every of like both I and j. So in a simple loop, uh, in a simple for loop, I think is it will be very hard to run a loop in that case. Yeah, because you cannot have the answer for both the previous and the next state to at the same time, I think. And you need that to create the answer. Or yeah, can it can be done, because when we need I minus 1, we need the jth arrow row or jth dimension, but we need, when we need I plus 1, we need j minus 1th, which should have been, which would have been solved already. So, and when we need j plus 1, it is for k minus 1. Okay, so I think if we run a loop, of course from 0 to the count or mp 1 less than equal to I plus plus for int j is equal to 0, j less than equal to mp to j plus plus for int k is equal to 0, k less than equal to mp 3 k plus plus, and we'll put the base case here. If I is less than equal to 0, or j is less than equal to 0, or k is less than equal to 0, the dp will be 0. Okay, otherwise we have our dp as dpijk is dp I into and we need the double I into dp of I minus 1 j k plus j dp I plus 1 j minus 1 k plus dp I j plus 1 k minus 1, of course k also. All of this divided by I plus j plus k. I need to put all this in the okay, all set. So this is the dp, and at the end we'll just do dp. Of course we need to set the precision to 10. Count 1, the answer is 0. Why? If we have only one plate, then expected move is 1 only. 1 by 1 multiplied by 1, that is the expected answer in that case. So he did n there because probably when we have a state where there is only like state which state like 100, so in that case this will be 0, this will also be 0, and this will be 1, but and this will also be 0. Okay, so the entire thing will be 0, but the answer is not 0 because we have one way, right? So in that case or maybe I should add that as a base case. Okay. Else if I is double equal to 0 and j is double equal to 0 and okay, it didn't work. Let me try to do it with the recursive solution. Divided by double and instead of this we'll do this. Let's see. I don't see any issue here in my implementation, but still it is not working. Why? I'm muted again. Okay, so it is a what is MCM type problem, and I'm thinking of the partition and then the how the answer will be updated, and that's where I'm stuck right now. Okay. Okay. For 10 and 20, we start from here. We end it here. K is initially here, and then K goes here. So it is partitioned as right now as 1 1 and 2 2, and we know that the answer for these is nothing but 0, since we are not combining anything, we are just at a single slime, so it will be 0, and this 0 combined with this 0 and the whole answer, what will be the total answer? It will be nothing but the cost of combining these two, so it will be a1 plus a2. So what we are doing is we are doing ai plus aj plus dpi and dpi dpik plus dpk plus 1 j and k will go from I to j. Okay, and this is not correct, this is the correct version. So this is the transition, and our answer will be obviously our answer will be in dp1 to n. Okay, so let's implement this. We don't need all this, we need this. Okay, let's remove all this. We don't need this, we also don't need this. Take input for one of the, I like this test case, so I'm taking this as input. Okay, we have n, we have taken the input I, and okay, so this can exceed 32-bit integer, so okay, answer can exceed 32-bit integer, and then we will have our dp, and it will go from n plus 1 to again n plus 1 and initialize with 0. Okay, and we'll run the loop. In the loop we will go from the start. So basically int I is equal to n, I greater than equal to 0, I minus minus, and int j is equal to 0, j less than equal to n, j plus plus, and here we will go for int k is equal to I, k less than equal to j k plus plus. Okay, and if I is double equal to j, in that case dpij is 0. Okay, okay, this doesn't make any sense, so we'll go from I only. Else what we will do is dpij is minimum of dpij, and this thing will be 2014, comma ai plus aj and not going from plus dp ik, okay, ik to dp I, or rather k plus 1 j. Okay, and the answer will be in dp 1 n. Let's see. Seg fault, where? Think here. Okay, here. Seg fault here. How? So we are going from n, okay, k is going from I to j, okay. Okay, so we are accessing k plus 1 here, and we are going from I, so it will not work. Let me go from the opposite side. Okay. j minus 1. Need to look at the DP table. Okay, so the thing is that we are not adding the individual uh, sizes, we are actually combining them, right? So if we combine this portion and combine this portion, then we are actually adding the total size. So we need to have a prefix array for that, and yes, I've did that only, and it seems it is working finally. Yep, it is working, and I'm going to submit it, and let's see what is the result. Okay. TLE, MLE, wrong answer, anything. TLE, MLE, wrong answer. Okay, so it worked, and yep, we are done with slimes also. Matching. There are n men and n women, both numbered 1 to n. For each ij, the compatibility of man I and woman j is given as integer aij. If aij is 1, man I and woman j are compatible. If not, they are not. Taro is trying to make n pairs, each consisting of a man and a woman who are compatible. Here, each man and each woman must belong to exactly one pair. Find the number of ways in which Taro can make n pairs. Oh shit. This is not doable today. Independent set. Tree with n vertices. Okay. Okay. This is a DPN trees. I'm looking forward to it. Flower. Okay. There's very interesting problems. Walk. Directed graph. For each, you are given an integer aij that represents whether there is a directed h from vertex ij. So there is a directed or not. Number of different directed paths of length k in G. You will also count a path that traverses the same edge multiple times. Oh shit. Yep. So sushi is a problem that I will come back to, and candies is also a problem that I've still not solved, so I will come back to it. Slimes are done, and sushi today. So yeah, that is it for today, guys, and I hope that you will have a very good night, and let's meet tomorrow with another problem and more knowledge on how to solve that graph problem and the tree problem, because I don't think we'll be able to solve that flower in tomorrow's stream, and we'll see which problem we'll be able to solve. Okay, so yeah, have a good night and peace.